Welcome back everyone. Now we are going to see that what is instruction pointer that we have left in the only left part in the VIU. So let's get exploring into that one. Before we learn that, I would like to introduce you with the offset address that I named it. So what are the offset address? So instruction pointer is one of the offset address. So let's explore that what the offset address actually mean. So the offset address is actually the displacement. The displacement means it's traveling of the data that we are talking about here. The displacement of of memory memory locations basically. So memory locations from the starting location locations actually, because there are more than one location for sure of the segment. Well, if you are the science student, you must get curious that why we have not used the word distance or just simply traveling, and why we have used the word displacement here. Because if the data goes again from microprocessor without getting processed, just presented something and go back to the memory, like this is the microprocessor and this is our memory. So with the help of the offset addresses, something comes in, fetched in, and we are able to see that data. It is going to get displayed on the output screen, but nothing is processed. Well, even in this case something is processed, but this is just a simply displacement. If output is discarded because of any reason, it again goes to the memory. So back to the memory displacement, so there is no change. So displacement is zero. Well, if you're the physics student, let me satisfy your curiosity with a simple example. And if you're not, you can follow up this example to understand this completely. There are the 2 points, A and the B. Well, let's name our stick person. Oh, yeah, it's me. Okay. So I travel from all the way to A to B. Let's say this is 10 units. And then again I decided to go back to position A. So what is my final displacement? Well, by the vector addition, I am having plus 10 and minus 10. Minus 10 because I traveled in the opposite direction. So plus and minus is just telling us about the direction. So overall the answer is 0 units. So according to physics, to the vector physics actually, I have never really actually traveled. Well, that's exciting, right? So what this thing is doing here, because there should be no data or something like that is storing the distance, that how much distance is traveling. It's just working. If it when it's not working, it just again has to go back into the memory. That's it. That's why we are using the word displacement here. Okay, I hope I have made your revision, made a short revision of the physics thing here. Okay, so this is about the offset address. Now, what we're talking about here, well, first of all, let's get introduced to a formula. Now, I'm going to make you the processor yourself. So now you are the processor. So what is the formula you are using to find the physical address? Yeah, this word is very important. Physical address. So what we mean with the physical address? Actually, the data that is there is physically stored in the device, like I said, RAM. So in the RAM or in the ROM, there are so many sectors, especially I'm talking about the ROM. So there are so many sectors where the data can possibly be millions and millions of places. So where we look at that, and it is actually physically stored in the device. So how the microprocessor is going to get the data, and that too in the fastest possible manner? So it has to use some formula. So the formula for that is segment address multiply 10, and you have to add offset address, and here is our data. Like, let's take an example to understand this. We need to find the physical address of a data, which is, let's say, phi. We want the address of the phi of the physical address. So if we have segment address as, let's say, 8, and we have offset address as let's say 11, so what we are going to have according to the formula is 8 multiply 10 plus 11. So it is 80 plus 11. This is going to be 91. So this is the location of phi physically present on the device. So this is the formula. Why the 10? Well, there are not very clear logic for that I am giving you, because surely you can change that, but according to the rules we are following it. Like, you can imagine it's 10, so 0 to 9 maybe 10 sectors that way. So segment address multiply 10 plus offset address. Well, there's also a simple way, the my way thing, that we can have it here. Obviously, there is something hiding inside your mind. Tell us that what it is, Om. You can just not give us this crappy thing that something is happening without any kind of logic, or at least some kind of the funny imagination that we can have. Okay, so let's imagine that Mr. MUP, yeah, microprocessor, Mr. MUP is thinking that how do I find the home of a person? Well, this looks like the heart. This is the best home I know that I can draw. So, well, nothing much about my drawing right now. Okay, so what we are having here, it requires the street address, house number, maybe the pin code, and maybe other such details. So this is the way we write the address, like A256 Stanford Street Park, and that this is this all much things. Well, this is not my address. Okay, so this is the way to find a home, address of a home or office or wherever you want it. Same way, to find the data physically that is stored inside our disk is this one. So now I hope you got its importance too, and this is actually important. You just need to remember very short formula for this one, and then you can find physically where the data is present. Okay, now finally, what is instruction pointer, the final thing for BIU part? So here we have it. Just give me a moment, changing the color. Instruction pointer, instruction pointer, the full form of the abbreviation IP. Okay, so what it is? it's a 16-bit register. Obviously everything is registered. That entire thing that we have seen here is segment register. Segment register. So this entire thing is nothing but the segment register that we have. So everything is actually that register. Okay, so this is 16-bit register used to hold the address. Obviously everything is storing, using and patching the address of the next instruction. So that's it. That's the definition. So the keywords that you can remember from this one is 16-bit register. Well, everything is 16-bit obviously, because 8086 is a 16-bit register, 16-bit microprocessor. So 16-bit register obviously used to hold the address of next instruction so that it can be fetched quickly, quick fetch, and then it can be sent to our prefetched unit, that is 654 and that thing, and there it will going to go in the control unit if required, and then finally it will go for the execution unit where the things is actually getting executed. So this is the story for that. Okay, so what about the instruction pointer? Well, what if I tell you that I already told you about the instruction pointer a long ago? Well, where? Let's find out. Okay, I'm just switching the slides. Let's see that if you can find that very beginning of the slide. And also, this will be a quick revision too, because I'm wrapping the instruction pointer with this video for this one, because we have studied the PIU. Okay, let's find out where it is. Well, did you got that? Not till now, right? Now you have got it. Congratulations. So this man who was standing outside of a clinic, well, this was a clinic, this was our doctor, these are the patients waiting in the queue, and this is our staff, the person or whichever you would like to call him. So he is helping us to queue the next instruction, next patient, right? So this is our instruction pointer. So this is our instruction pointer. So we already learned about the instruction pointer long ago. Okay, with that, I'm keeping this one till this point, and in the next one we are going to see what is execution unit, and we are going to explore that. And with this one also, I would like to congratulate you because you have studied one complete part of the BIU. Now you can say that you know what is BIU on every aspect. You know it. Well, the only thing that is remain is just open a 8086 and see that yes, it's here. And this is the ALU. Well, I think I already told you about this one. We are going to discuss the ALU again in the execution unit, so we keep it for that place. So that's it for this one. Take care, God bless, and see you in the next one.